Hello everyone, welcome to Method 24 review for second midterm. So today we can go over our my fixed exam number 12C and 12D. Let's start it. So question one it is hi comment. So we just go over my fixed exam from 12C and 12D. So now just go over so if you did any problem from a fixed exam, just ask me questions.
Hello.
This is just my exam. I just made them now to go over it. So for problem one, it is here like use a chain rule. You say inside the function it is 12x to the 13 minus 14x, and for outer function is x and this x to the 15th, and you just and it's a chain rule, and you got like I got to like 15 times 12x to the 13 minus 14x to the 14, and this inner function you get like the ddx. For this, you get like 156x to the 12 minus 14. And for plus this, here's the e. And also use the chain rule. Yeah. So here is the e to the u, and you get like here's the final answer. 15 times to 12 to the 13 minus 14x to the 14 times 156 times 156 x to the 12 minus 14 and plus 16 x e to power to 16. 17. Do you have any questions on problem one? I think this is basic chain rules. So if you have any questions you want to ask, just feel free to ask me. Yes, for chain rule, we call from 3.4, 3.5, 3.6, 3.9, and then like 3.10 and 4.1. So it is from chain rule like implicit logarithm to like implicit differentiation to like the rate problem, like a tangent approximation. And he's just like the max and the min. His parametric equations will be 10.2. So problem two is compute the derivative. This logarithm differentiation. So we take so we take like a natural log on both sides. So we get a natural log y, and the right side should be natural log of x times the natural log of the, and times the natural log of the sine 12x. And here you can this can compute for 1 over y is like the derivative, and you got like 1 over x is the derivative of being x. Here's like use the product rule. Here's just a product rule here. And you want to get this rate of 1 over 1, right? And you times by y. The y is this function itself, sine of 12x to the 12 to like natural log x. Yeah, actually, this is already being recorded, so we'll be posted later. This is I already hit the record button so fast, so it's already recorded. No problem if you miss it or something, because this is recorded. We'll post by tonight, and you can get out this 1 over y to times of y. You'll be cancel and you'll be 1 here. You will for like dy over dx will be sine of 12x top to the top to like ln x times this whole stuff. Then this is your final answer. So if you have any questions about problem number two, are you all good about number two about like a logarithm differentiation? Any problem want to ask? Yes, Yes, like yes, the derivative of ln x is just 1 over x. So is that all question you want to ask? Now we're going to question number 3. The third problem is another chain rule. So it is just like the chain rule is in that 2x minus 2 minus x like 15, and the alpha is the inverse sign, and then plug in the trig identity, and you got 2 minus 1 over u squared. Then you get this is the final answer. So like problem 3, it is like very straight chain rule and the inverse trig identity. I think this will 3.3 and 3.4. So I don't think this is a big problem of the test because like I believe we use the chain rule all the way to the end of the quarter. Just like you need a chain rule for like your final, for like and like for second midterm. For problem 4, this is implicit. Here you use the product rule first. You get 6x 6x to the square times y to the fourth, and you get like this is 4y to the third, and you get like 12x is the derivative of this and times y to the fourth. And for every y gets like the same, you pull this out. This is y third, and you get dy dx because implicitly with this is just pull out like a 3 to the here, which is 36y to the square, and dy dx, and minus 12x to the 12xy to the 4 to this side, then you get this. And you combine two terms together, you will get 24x 25x squared to y to the third minus 36x to y to the square dy dx, and you how you compute dy dx is just to adjust this over this. This is your your equation, and here's the point is a 1 and 2, and you're plugging in x equals 1 and y equals 2 here, and you got like a negative 47 over 12. That is your slope of a tangent line. Any questions on problem 4? Sounds good. Then you go to problem 5. So problem 5 is just like the relative rate is like the application of the derivative. So like the best way just to draw like graph and know and label every single data you have. And now you know that dxdt is this side is like he walked from the wall to like this to the flashlight. It is moving to like a negative x way. So dxdt then moving this should be negative. It is not positive. This should be negative because it'll be moving from right to the left. Then like the speed will be negative. No, that would be like the velocity will be negative. If she's moving from the flashlight to the wall, then the activity will be positive. And we need what is dy dt? He's her shadow on the wall is this y. How the shadow changing when x is 21, when this is 21. And this is like a right triangle, so we have like a ratio. So 6 over x equals to 42. This total is 42 is y over 42. And you compute like c dt, compute the, and you need get a dxdt, then you need to compute the derivative of this, and you got like to 6x power to like -2, and I don't forget the sign, it is negative, and you got dxdt, and and then you got dy dt, it is this, and you plug in, and you got y over 42, so this is 1 over 42 y times ddt, and you get y here, you have 1 over 42 left, and then you get this. Now you put a number in there, dxdt is -3, and I just put a number on there. So that's it. It's like, and then like you need to be x is 21. You plug 21 here, and you get 2 over 49 equals 142 dy dt, and you get the dy dt is equal to 84 over 49. Any questions on problem 5? This is really traditional, really actually this is really good over like related rate problem. Any question on problem 5? Are we all good? We're still there. We move to problem 6. Problem 6 is tangent line approximation to estimate the value of like this number. So we rewrite this as actually the 1/3, and how to do it is to find fx is the original function, and to find your f prime x is the derivative. Yes, I have problem 6 and problem 8 left. So I will be, yeah, so it will be quick. So the I prime x, and you just pulling, and you know when x equals 8, this is only function, and is equal to 2, and you will see like the final answer will be close to 2. And you're plugging the 8 as the f prime x, and you get like this. It's just like the slope of like the approximation. And you're just putting the x. This is what you need for x. And you put x as here, and then plugging here's the x, and you got 1 over 12 is 0.836 times 7.77 minus 8, and then plus 2. 2 is the original function value, and you got 1.98.083. So it's 1.98083. This is the final answer. And last part, because problem 7, there's some wording problem, so just take it out. So if you did this exam you did not do problem 7, no problem. You add 13 points on this exam, because this problem is kind of a typo. Sorry for the mistake. Problem 8, it is the critical point is when the derivative it is equal to 0, and the y to the prime is 722x to the square minus 24x. You factor 24x out of here, without x equals 0, x equals 1/3. So those are two critical points. And this is the interval here, and you find the local max. It is the largest output over the interval and like a critical point. There's four number you need to put in to the original function. If you put x equal to 0, and you get 8. If you put x to the 1/3, you got like 68 out of 9 over 9. If you're plugging the lower end of your interval, f f when actually to like -2, and it got output is negative 200, and it's like negative 232. If you put like the upper bound of your what, or never mind, because like for this is what is on like a regular quarter, like the measure 24, but now just tell you like the critical point it is when their derivative is equal to 0. This is like how it is critical point. For like the speed of parametric equations, usually like the square root of their derivative to like the square. So x prime t is 8t to the third minus 6t, and y prime of t is this. So you put them on there, and when t equals 4, and just put them when they equals to 4, then compute. Here's like the speed is like square root of 4512. So it's like a typical advice for the exam. It is, assume your professor calls like 3.10, and one piece of advice is like, since like all like regular, because I made this exam based on what I learned for fall 2020, but yeah, but I think it's better to look at like this will be on the final. But now you just know this thing, but this will be on the final. So again, just remember all like the formula, like a chain rule, trig identity. Make sure there's like a minus sign or like a sign. Don't mess up with the sign. Make sure your computation is right. Just to show all your steps, because that just show your professor you're actually doing real work. Because like if you're doing like the online, like an online problem solver, then just give the answer, and just to like minimize the chance of professor just accusing you of cheating, just to show all your work. And then the logarithm differentiation, just to take like a natural log y to both sides, and just times by y to, and then just get all this 1 over y and get this, and then get this co-equation. And make sure if you see cosine over sine, then it's a cotangent. If you see sine over cosine, it is tangent. Just to get a trig identity here, because your professor might take point out. Because of this answer, because it didn't fully just. It is not kind of like the thing, because you need to do the cosine over sine tangent. If cosine over sine is cotangent, tangent over sine over cosine is tangent. But this is it's a radical. I think this is like the denominator. Simplify just label it here. For this like kind of relative rate problem, just to draw like the graph, and then just to show better your like understanding. I think that is like my piece of like the advice on like the exam. And then I assume the midterm is 80 minutes, and assume there'll be 8 to 9 problems total, because like your test may be like only say 4 or 5 problems, but actually they're like 8. Some problem might be like multiple parts. So make sure don't spend 9 or more minutes on one single problem, because you might gonna be running out of time. But thank you for coming to my exam review, and hope you guys have a great night and just get extra sleep. Just make sure you sleep before 12 a.m. at midnight. And I will end this recording. I will stop share my screen, and This will be, I will send a link to the video tonight on Discord. You can just rewatch if you feel like any like this struggle on the exam. Here's from 12C. 12B, it is basically the same exam but just change the number. So if you feel like struggle any 12C or 12B, just rewatch this video. Thank you everyone for coming to my exam review. Good luck on your exam. I trust that you can do well. Just don't be too much stressed because it's just an exam, just nothing else. Try your best.